Hello again and welcome to another Rubber Ducky video. Last time what we did is we created the transpose function, the sumMatrix function, and the new constructor for our matrix class, which created a matrix out of a two-dimensional array of doubles. The problem is now that the sumMatrix function does not work as intended. So instead of printing out x.show, let's see what x is. Instead of printing out a submatrix which contains the submatrix 0, 0, which is the submatrix without the 0th row and the 0th column, which is just this part, 12, 13, 14, 22, 23, 24, it printed out 0, 0, 0, 0, 12, 13. So apparently something's a bit off right here, and let's try to find out why. Here in the submatrix, something's going to be terribly wrong about the what do I call it? The extra counters that we used. So let's try first with the 0, 0 case, where it goes into this for loop. I is equal to 0 and the I counter increases, but the continue, it skips ahead, so it doesn't write anything at this element, and it goes right to the next column, so it doesn't write this column at all. So I think this is the problem. These continues here were not necessary. In which case, let's press Control Shift F6 and something went out of bounds. Which was it? That's a nasty error. So 5, something went to 5. And I would really guess that it's a J, because it's the J's that go up to 4 and something's going to go up to 5. But why? Submatrix 139. Yep, so let's do it the hard way and use a verbose reporting of the counters that we have right now. So print f, I will open two parentheses, one with the counters of one matrix and the other with the counters of the other, and \n I, j, I this, j this. Let's run this again. So as expected, it begins with 0, 0, and this counters begin at 1, 1. At the next iteration, it goes for 0, 1, 1, 2. It begins from, it reads the original matrix from 1, 1, and then it goes to 1, 2, and then in 1, 3, and in the next. Oh, wow, why do you look at that? I should reset the counters, which I really didn't do. How silly of me. So every time we enter this for loop, and I should reset this counter, and since j underscore this is not used anywhere else, I should define it in here instead. So right outside the for loop, which is exactly what happens for the I. Yeah, I think this is a much better approach. Yep, that is correct. So the resulting submatrix is 12, 13, 14, yes, and 22, 23, 24. Now let's try 0 row and the first column. Let's run this again. So let me erase this. It has no place here. So it is 11, 13. So now we delete. So between those two shows, or maybe better, inside the show function, it would be a good idea to print out two separators, above and below. Therefore, something like this and something like this, just for kicks. Yep, much prettier. One more dash here. So now, removing the 0th row and the first column, 0 row and the first column, we are left with 11, 13, 14, 11, 13, 14, 21, 23, 24, 21, 23, 24. That's right. So if we go with 3, 3 for a final try, that's 0, 1, 0, 1, 2, 3. We remove 0, 1, 2, what? It removed the second. If we remove the second row and column, we are left with this thing, which is correct. 0, 1, 2, 0, 1, 2. It removes one. It leaves us with 1, 2, 4, 1, 2, 4, and 11, 12, 14. Yes, but in the case of 3, where it gets out of bounds, how come? Well, I mean, it's illogical that it removes this. It removes this row. It should remove this, the third row, the third column. What about now? So if we're out of bounds, it removes the last one? That's what you're telling me? Well, maybe that's something that should be fixed. I will check that out, but later. So let me put here a to-do. Bug when m is more than n. Argument m is more than size m, and argument n is more than size n. Now, just for the sake of it, let's ask ourselves what will happen for -1 case. Well, that's not fun at all. It removes. Well, it removes things that should not be removed. I mean, if there's a negative number here, I think that I'm gonna solve it. I'm gonna fix this bug without even before moving on. Anyway, so if this number is negative, there is no jumping ahead for I dot this. No, Oh, now I regret removing the printing function, but let's do this again. System out, print. So 1, 2, %d, 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 and \n. Here I get I, j, I, this, j, this. So 0, 1, 2. So the extra elements are definitely so the resulting matrix is already smaller in size. So if something gets removed that is not so the resulting matrix is already smaller in size, which means that if you won't find the m within the boundaries of the original matrix, it will just start copying until it doesn't have any more space, and copy again until it doesn't find any more space. So the default case is removing the last row and the last column. Interesting approach. But anyway, I don't think that's much of a concern. So I will remove the submatrix, and I think that's good enough for now. And instead of defining the determinant function, I would like for the next video to write down, before writing down these 4 functions, to create one more class. I can't remember this. New file, a Java class, which I will name vector. And vector will describe a one-dimensional matrix with a single column of data. That would be it for now. Thanks for keeping up with me, and we'll see you next time.